Hello, this is Mr. Stansbury. I'm going to take you through the 17B notes on quartic polynomials. All right. At the end of this, you should be able to say I can find x-intercepts and y-intercepts of quartic functions and graph the functions. You should also be able to say I can find local minimums and maximums of quartics. I know, that's exactly what you were hoping that you were going to learn. Yep. Wish granted. All right, so quartic polynomial is a fourth degree polynomial in the form f of x equals ax to the fourth plus bx to the third cx squared plus dx plus e. And then a, b, c, d, and e are all constants. Okay, so basically this polynomial is going to start with the highest power, which is the fourth power, the quartic, and then third power, second power, first power, zero power. All right, so if a quartic is fully factorized into linear factors, for a single factor, the graph is going to cut the x-axis. All right, and let's just take a look at some pictures with this. That should hopefully help out. So if this thing basically is not in this form, but in the factored form, where you get all of these pieces factored out like this, anything that's to the first power, the single factor, is going to be something that cuts through the axis like this, cuts through the x-axis. If it's squared, it's going to come up and just touch it, or like bounces off of the x-axis. If it's a cube, it's going to cut through the axis, but more at a flat line here. Instead of cutting straight through like so, it's going to kind of wiggle through. And then a quadruple factor, to the fourth power, it's going to come down and touch the axis again, but it's going to actually kind of flatten out. So it flattens out a little bit. It doesn't completely get flat, but it does flatten out a lot more than just the squared factor. All right? Okay, so we are going to take a look at an example with this. And that is for the graph y equals x minus 2 squared times x plus 1 times x plus 3. We're going to use technology to observe the function and sketch a graph. And then we're going to find the axis intercept and also find any local maximums or minimums. All right? So, you know what? Let's start graphing this thing without technology first, just so we can kind of better understand it. Okay? So, x minus 2. That means we are going to need to put in a 2 here, because 2 minus 2 gives us 0. So we have a double factor at where x equals 2. So here's 2, and there's a double factor right here. Let's use a better color here. So there we go. Okay, right there at 2, there's a double factor. So since it's a double factor, I know that this one here is going to bounce, right? Or just be the one that just touches right there. Okay. This factor here, x plus 1, we need a negative 1 plus 1. So that means we have and that's to the first, and this is to the first. So this is a single factor at x plus 1. So negative 1 plus 1 is going to be our single factor. So right here is another factor, and this one here is going to cut through. And then we got x plus 3. So negative 3 plus 3 gives us 0. So we have another one. Negative 3 is right here. So both of these things here these are going to be cutting through. Okay? So we at least know that. And then we also know that since this here is positive, it's going to end up here. So again, it's going to look something kind of like this. It's going to come down here, and it's going to just bounce off of that. Come back up here at some point, cut through here, cut through there, and come back up and look something like that. And that's just a big, huge mess. But hopefully you can kind of get the idea. Here's roughly what the graph looks like. So let's get rid of that graph there. And then let's actually take a look at this with our graphing calculator. All right, so I'm going to get rid of this business here too, and I'm just going to leave these points on. Okay, so get rid of all of that. Whew. All right, So again, this one was -1 and this one was -3. So -1 and -3. These are our x-intercepts. All right, graphing calculator. Let's turn this thing on, and we are going to observe this by putting this function in here. So I'm going to make it look just like it looks here. I'm going to do x minus 2 squared. And then I'm just going to use the parentheses, make it look just like this. X plus 1 and x plus 3. All right. And then again, we're going to graph it. And remember, this is from an old graph here, so that's just a big mess. So let's do, actually, let's not, instead of doing window, let's just do zoom standard. And it should at least give us a better idea what it looks like. Okay, so that's pretty close. We are just barely missing that. So let's see if we can do a zoom out to get a better look at this here. You gotta hit enter twice and it'll zoom out for us. That's too far out. So let's do our window. Instead of -40, let's just do, say, -20 ought to do. And then the maximum, let's do 20. Oh, that's x. We need x just to be, say, -10. We don't even need it to be that far. Let's do -5. You could do -10 too, that'd be fine. But from -5 to 5, because we know that here's -5 and there's 5, and we know that it's going to fit within there. So x scale we can leave at 1. Y minimum, we want that's the one that we want to be down at -20. And then the max, we don't need that one very high. Let's just go to 10, and we'll make this by, say, 5s. And then we graph it. Oh, nuts. I just missed the top one. So window, we need that Y maximum to be, let's do 20. And then graph. All right, now we got all the pieces on there. So really what we're looking for, we already know there's our -3, there's our -1, and there's our 2. We already know those. We want to find this maximum and this minimum. So we're just going to use the calculate function. So let's find that minimum first. Oops, minimum. And again, we got to get, it says left bound, we got to get to the left side of the minimum. So we got to scroll this over until we get to the left of the minimum. Push enter, and then we got to get it over to the right side of the minimum. Push enter, and then it wants us to guess. Yep. So -2.22, and the y is -16.9. So let's do -2.2 and -16.9. So minimum -2.2. That is not a 2, that's a 2. And -16.9, I think, was the other piece of that, right? -2.2, -16.9. Okay, that works. And then now let's calculate the maximum. So second, calculate. Go to the maximum. And again, left bound, we want to get it up close-ish to the maximum. There's that. And then there's to the right. Then we put enter. It's going to find the maximum in between those 2 points, and that's a maximum of when x is 0.2 and y is 12.4. 0.2. Did I say 14.4? 12.4. All right, so let's change that. 12.4. All right, and that's our max. Okay, so all we need now is to just graph those points and put our, that'll be our minimum and our maximum, and we can graph the rest of this thing. Okay, so -2.2 and -16.9 is going to be, let's just pretend, since that's as far down as we can get. Actually, you know what? There we go. So there's -16.9, almost down here at 17, so we'll say it's about right there. Okay, and then our maximum is at 0.2, so barely to the right of this, and at 12.4, so it's about right there. Okay, so there's all our points, and then I'm going to cheat and put our graph on there. Whoo, look at that. There's roughly what our graph looks like. Okay, and then it says, let's see, I think we've done everything that we need to do, don't we? So let's just label these points here, which I cheated. Oh no, that's in the way. Let me get rid of that first, and then we'll take a look at that. All right, sorry, here we are. So here we go. Here's our local maximum at 0.2, 12.4. Our 3 x-intercepts at -3, 0, -1, 0, and 2, 0, and then our local minimum at -2.2 and -16.9. All right, so now with that, you should be able to say I can find x-intercepts and y-intercepts of quartic functions and graph the functions, and also I can find local minimums and maximums of quartics. All right, if you have any questions, please ask. Thanks.